Good day, everyone, and you are welcome back to class. We are happy to see you today again, and we want to celebrate your effort for coming and always checking on us so that you can learn and advance your mathematical knowledge. We love you. I want to salute your efforts. Keep coming and keep learning, and the Lord will bless you as you do so. Amen. Let's quickly take our confession before we continue with the class. My memory is blessed by the Lord. My understanding is enhanced by the Spirit of the Lord. My assimilation is accelerated by the Holy Ghost, and I excel in my studies. Amen. If indeed you took that confession, I want to pray and trust the Lord that the Lord will help you even to understand everything that you will learn today from this channel. Amen. In our previous videos, we have recorded 2 videos on probability. We have talked about probability, mean of probability, and we have probability 1, which comprises of mean of probability. Then we have 2 other aspects of probability in probability 1. Then we did second video, which we talk about mutually exclusive event, which is the addition of probability. And this is the third video on probability. We trust God to be able to finish the rest of probability, but if you can't finish it, let's see how far we can go in this video. Thank you very much. Now first we are taking independent event. When we say independent event, what does that mean in probability? A probability is said to be independent when you have 2 or more events that can happen such that the occurrence of one will not affect the occurrence of another. A probability is said to be independent when the occurrence of one event does not affect the occurrence of another event. Example of such is when you say we are rolling a die 2 times. When you roll a die 2 times, if the first outcome is 2, that the first outcome is 2 will not stop the second outcome from being 2. When you have a ball, when you have like 5 balls, we have green ball, we have blue ball, we have yellow ball, we have black ball, and we have white ball in a sack, and we decided to pick 2. If we pick the first one, if it is yellow, that we pick the first one to be yellow. If we want to pick the second one, we can equally pick another yellow. That is what we call independent event. 2 events that happen such that the occurrence of one will not affect the occurrence of the second one. That is what we call independent event. So let's quickly take brief examples of independent events. Now let's quickly solve these questions and see how to tackle problems relating to independent events. Number 1, 2 dice are thrown once. What is the probability of getting to 6? Probability of getting to 6. That is, in a die, you can get 1 6 in a die, and that is 1/6. Then the second time, you can get 1, and that is 1/6. Now, listen to this. Okay, let's make it simpler. This is the same thing as saying probability that first 6 and second 6. That's the meaning. So, everybody, the probability of getting 6 when a die is thrown is what? 1. If you still remember, in one of our previous videos we explained it, because there are 6 sides in a dice. A die has 6 sides, and you cannot just get more than 1. So probability of getting 6 in a die is 1. over total outcome, which is the total number of faces this die has, which is 6. And don't forget, when we talk of independent event, we are talking of multiplication of probability. And in most cases, independent events used to use and. So anytime you see and in probability, we are talking of independent event. And when we talk of independent event, we are talking of multiplication. You are going to be seeing more of that. Anytime you see and in probability, we are multiplying. And anytime you see or in probability, you are adding. So it means the first one is 6 and the second one is 6, which is also 1 over 6. And that will give us 1 times 1, 1. Then 6 times 6, that is 36. And that is the answer for A. Then B. We are told that two prime numbers, two prime numbers First, before we solve that, let's quickly see the prime numbers that we could possibly have. Don't forget that between 1, we are talking of a die which is between 1 and 6. So between 1 and 6, you can have how many prime numbers? Prime numbers between 1 and 6. First, what is prime number? Prime numbers are numbers that can only be divided by themselves and 1. Prime numbers are numbers that can only be divided by themselves and 1. So between 2 and 6, we have 2, we have 3, and we have 5. These are the possible prime numbers between. These are the two prime numbers between 1 and 6, which is the number of faces of a die. So, having understood that, they now said if the two are prime numbers, so what are we going to have? Probability of what? Two prime numbers will be probability of 2, 2 or 3, 3 or 5, 5. Please, do we get that? So that we can have 2, 2, 2 and 2, 3 and 3, 5 and 5. Do we get that? He said that the first one is 2 and the second one is 2. The first one is 3 and the second one is 3. Then the third one is 5 and the second one is 5. So it's either you have 2 and 2, 3 and 3, then 5 and 5. So that will give us what is the probability of 2 in one die. Don't forget we said that will give us 1 over what? 6. 2 in one die is 6 and the second one is 1 over 6. Or means plus. The first one here is 3, which is 1 over 6, times this, and the second one is 3, which is 1 over 6, then plus, the first one is 5, which is 1 over 5, multiplied by the second one, which is 1 over 6. Please don't make this mistake. We are just talking about the number of 2 that we can see in one die. Number of 2 that we can see in one die, that is 1. And what is the number of faces in one die? That's 6. That's how we got 1 over 6. 3 that we can see in one die, that's 1. Out of the total faces of a die, that's 6. Then 3, 1. Then over total number of faces that we can see in a die, that's 6. Then that is how we got that. Now, that will give us 1 times 1, 1 over 36, plus 1 times 1, 1 over 36, plus 1 times 1, 1 over 36. And that will give us 1 plus 1 plus 1, that's 3 over 36. And that will give us, divide by 3, 3 by 3, 1. 3 here, 1. 3 here, 2. 1 over 12. That is the answer for the B question. So let's quickly take the C question. C. Now, C is saying that when you have one odd and one even, one odd, one even, the probability of having one odd and the other even. We now said that is probability of having one odd or even. So we try to we said, how many odd do we have in one die? That is between 1 and 6. How many odd numbers do we have between 1 and 6? Odd is 1, 3, and 5. Then how many even number do we have between 1 and 6? That is 2, 4, and 6. So we said the probability of having one odd and one even. So the next thing is to combine the odd with the even. So you have, it's going to be probability of having one odd, 1, and one even, or one odd and one even, or one odd and one even, or is the probability or now second odd, 3 and one even, or 3 and 4, or 3 and 6, or third odd, which is 5 and 2, or 5 and 4, or 5 and 6. Please, do you understand what we just did now? The first thing that we did, for better understanding, the first thing that we did is to list out the odds that we have from 1 to 6, which is the number of faces in a die. Odd number 1, 3, and 5, then even 2, 4, and 6. The question says having one odd and the other even. So you pick one odd, one even, one odd, one even, one odd, one even. Then one odd, even, odd, even, odd, even. Then the third odd, 5 and 2, 5 and 6, 5 and 6. This is 5 and 4, 5 and 6. So that's it. So now that will give us the probability of having, so that will give us what? This is probability of having one from a die, from the first die, is 1 over 6 times probability of having one from the second die, that's 1 over 6. Or means plus, don't forget. Probability of having one in the first die is 1 over 6, and second one is 1 over 6. Or means plus, as I said earlier, 1 over 6. Probability of having 6 in one die is 1 over 6. Or means plus, probability of having 3 in one die, that's 1 over 6. And probability of having 2 in one die is 1 over 6. Or means plus, probability of having 3 in one die, 1 over 6. And 4 in one die, 1 over 6. So are we getting in place? Alright. Or means plus, probability of having 3 in one die, 1 over 6. And probability of having 6 in one die, 1 over 6. Or means plus, probability of having 5 in one die, 1 over 6. probability of having 2 in one die 1 over 6, or means plus probability of having 5 in one die 1 over 6, probability of having 4 in one die 1 over 6, or means plus probability of having 5 in one die 1 over 6, then probability of having 6 in one die is 1 over 6. Please, do you understand all these things now? You just see that everything is 1 over 6, 1 over 6. Somebody want to ask me, why is everything 1 over 6? It's because you cannot have anything more than 1 in a die. 1 is just 1, 2 is just 1, 3 is just 1, 4 is just 1, 5 is just 1, 6 is just 1 in a die. So that is why everything is 1, because you only have one required outcome. It's just one required outcome that we have. In 6, we have just 1 6 in the die. So that is why we cannot have anything more than 1, divided by the total number of possible outcomes, which is 6. Which is 6, so that's it. Now, 1 times 6, that's going to give us 1 over 36 plus 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 1 over 36 5 6 7 plus 1 over 36 plus 1 over 36, and that will give us, of course, you know the LCM is going to be 36. So 36 divided by 36, that will be 1. 1 times 1, that will be 1. 36 by 36, that's 1. 1, 1, 1, 1, 1, 1, 7, 1. So this is it. By the time you add all the ones together, you have 9 divided by 36. 9 we divide 9. We said we have 9 over 36. So 9 here 1, 9 here 4. So the answer is 1 over 4. I hope you understand that. Very good. So let's quickly go and solve question 2. They said a basket contains 3 red balls. Red. Let's make red to be R. It has 3. Then 5 blue balls. Blue balls. Let it be B. 5. Then 2 black balls. A ball contains 3 red balls, 5 blue balls, and 7 green balls. Green, that's G, that's 7. So we are now told that 2 balls are picked one after the other without replacement. Find the probability that 1, they are both red balls. So the first thing is you get the total. The total is 15. That's the total ball. So now, the total is 15. So the next thing for us to do is, what is the probability of red ball? Probability of having a red ball is what? That's 3 divided by 15. Probability of having a green ball, blue ball, sorry, that's 5 over 15. Then the probability of having a green ball, that's what? 7 over 15. Okay. Now, we are now told that the first thing is both are red. So probability that both are red, that is, probability that both are red, that is of R and R. The first one is R and the second one R. First one is R and the second one is R. So that is first one. Don't forget, there is a phrase here. They said without replacement. Without replacement. What does that without replacement means? Without replacement means that when you pick the first one, you do not replace it again. You do not return it back to the box. Do you get it now? You do not return it back to the basket. When we pick the first one, we do not return it back. Is that clear? Please, let's understand the term without replacement. It means when the first ball is picked, it's not returned back. When the first ball is picked, it's not returned back into the basket. So when you pick it, you remove it. Is that clear now? Now let's solve. First ball is red. That is, the first one is red. That is what the probability of picking red ball. We said 3 over 15. That's and means multiplication. Is that clear? Okay. Now, if the first ball is red, now the second time that you will pick again, don't forget that it was initially 3 balls that is there. So if we pick the first one, which means the ball will not be up to 3 again, it's now remaining how many? So you can now pick from the remaining 2 balls over. Don't forget we have removed 1 from the total ball. It's now remaining 14 balls. Do we get that, please? Do you understand what we just did? The first ball, the ball is still complete in the basket, 3. So you can pick from the 3, that's 3, over the total ball, that's 15. The second time, you've picked 1 the first time. So it's remaining 2 balls now that you can pick from. That's why you have 2. And the total ball have reduced because you have removed 1. It's now remaining 14 instead of initial 15. Please, do you understand that? Alright, very good. This 3 will cancel this one to give us 1 over 5. 2 here 1, 2 here 7. Then our answer is going to be 1 over 5 times 7. That's 35. Then B. First ball is blue, the second is red. That will be probability of blue and red. First one is blue and the second one is red. So what's the probability of picking blue first? Is still complete 5. That will be 5 over what? 15 times. Now, the second one is red. Red is still complete. We have not taken anyone out of red. This one, we said the 2 are red. First one. For the second one, we have removed 1. But here, we have not taken anyone out of red. So red is still what? Red is still 3. But red is still 3. But the remaining, we have removed 1. We have removed 1 blue. You know, we said total. Now we have removed 1 blue. The remaining ball will not be up to 15 again. So it will now remain 14 balls. Is that clear, everyone? Let me explain again. The first time we picked 1 ball. Are we getting it now? First time we picked 1 ball. We have taken 1 blue. Don't forget we said the total ball is 15. Now if you have now removed 1 out of the total ball, it will remain 14. That's why you have 3 over 14. Okay. 3 here 1, 3 here 5. 5 here 1, 5 here 1. And our answer now is going to be 1 over 14. Please, do we get that? Okay. Number C. Said both are of different color. Now, this one, we don't know the color that it is. They are not just the same. That we shall know. What we shall know is that both of them are not the same. So that will be the probability of having what? Blue first and red second. Or you have blue first and green. Or you have what? Which other one have we up here? Red and green. Or you have red and green. Just that the 2 are not the same. They are different. It's either you pick blue first and pick second red, or you pick blue first and pick green red, or pick red first and green second. So is that clear, please? Alright, so let's quickly do that. This, we said the probability of blue ball is what? 5 over 15 multiplied by that of red ball. What's that of red ball? So that of red ball is what? Red is still complete, 3 over 14. Please, do you understand this? Don't forget, as I explained here, we have picked 1 out of the total ball. So it's remaining 14. Or means plus. Don't forget, we said or means plus. Blue first, that's 5 by 15 times green second. Green is 7 by 14. Don't forget we picked 1. This one we are 1 is 1 as removed from the total, so remaining 14. Then plus red. That's what's the probability of having red ball? Probability of red ball, that's 3 over 15 multiplied by green. Green is 7 by what? 14. I hope you understand. Very good. So we now have, so by the time you find the LCM of 1 over 14, 1 over 6, and 1 over 10, that would be 210. So 210 divided by 14. 210 divided by 14, that's going to give us 15. That give us 15. Then you see 210 divided by 6, that will give us 35. That give us 35. And 35 divided by 210 divided by 10, that give us 21. Don't forget, whatever it is, you multiply with this. And that's going to give us 21. So when you add 15 plus 15 plus 35, that will give us 50, right? Yeah, 50. 50 plus 21, that will give us 71 over 210. That is the final answer. Now let's quickly solve these questions on probability of special cases. Number 1. Two hunters aimed at the target. The probability that the first hits the target is 1 over 5. Okay, we said let the hunters be P and Q. Do we get that? Okay, so first we hit it. Probability that P will hit it is what? 1 over 5. Then probability that Q will hit it is what? 2 over 7. So you have to find probability that both of them will hit the target. So probability that both of them hit it will be what? Probability that P hit it and Q hits it. And that will give us P hit it, that's 1 over 5, times Q hit it, that's 2 over 7. And that will give us 1 times 2 to 5 times 8, that's 35. I hope you understand that. Alright. Then B. Only first we hit it. So that is P will hit it. P hit it and Q misses it. That's what we should do. P hit it, Q misses it. So now the probability that P meets it, let's have another line here. Probability that P misses it, let's do it here. Don't forget, we said probability that, if we said probability that you hit a target is 1 over 5, probability that you miss it is the same as probability that you will not hit it. And anything we are talking about the negative order, we are talking about the other aspect. Like we said, rain will fall today. Probability that rain will fall today is 1 over 2. Probability that rain will not fall will be 1 minus probability that it will fall. So that will be 1 minus probability that it will hit it. Is that clear? So that will be 1 minus 1 over 5. And that will be 4 over 5. Then probability that Q misses it, that will be 1 minus probability that Q hit it. And that's 5 over 7. So this is what they said we should do. So from here now, we know the answer is P hit it 1 over 7, 1 over 5, multiplied by Q misses it. Probability that Q misses it, 5 over 7. So 5 can cancel 5 and you have 1 over 7. Please, is that clear, everyone? Good. Then C. Only one of them hit it. That is probability that P hit, Q miss. Or probability that Q hit, P miss. Because it's only one of them, it's either P will hit it, then Q will miss it, or probably that Q hit it and P misses it. So probability that P hit it is what? 1/5. Q misses it is what? 5/7, or set means plus. Probably that Q hit it is 2/7, or P misses it is 4/5. That will give us this one. 5 will cancel 5. 1/7 multiplied by 8/35. I'm sorry, 1/7 plus 8/35. And of course, the LCM you know is 35. So 35 divided by 7, that will be 5. 5 times 1, 5. 35 divided by 35, that will be 1. 1 times 8, 8. And that will be what? 13/35. So let's quickly see the D aspect of the question. He said both of them will miss it. That is, probability that P will miss it, P misses and Q misses. How P misses 4/5 times probability that Q misses 5/7. Okay, 5 will cancel 5, then the answer is 4/7. I think that is clear. Alright, so let's quickly take the second example. Part 2 said the chance of 3 independent events P, Q, R occurring are 1/2, 2/3, 1/4 respectively. What are the chances of A, P and Q occurring, B, P only occurring, C, none occurring, then D, one of them occurring? So this is, so probability that P occurs is what? Okay, you say let P, okay, let B prime equal to P will not occur, then Q prime equal to Q will not occur, and R prime equal to R will not occur. Okay, so now we say probability that P will occur now is what? 1/2. Then probability that P will not occur, which is P prime, will equal to what? Don't forget we said the other one we did, that it will occur is 1/2, that it will not occur, it will be 1 minus probability of P, that P will occur. And that will be 1 minus 1/2, 1/2. Then probability that Q occur is what? 2/3. Then Q prime will be 1 minus probability of Q, and that's 1 minus probability of Q, which is 2/3, 1/3. Then probability that R will occur is what? 1/4. Then R prime, which is R will not occur, 1 minus probability that R will occur, and that's 1 minus 1/4, 3/4. Let's quickly go and solve the remaining question. A says probability that Q and R occur, and that will give us Q occur, R occur. Probability that Q and R, that is Q occur, R occur. So that will be Q occur, Q occur is 2/3 times R occur 1/4, and that's 2 times 1. Okay, 2 here 1, 2 here 2. So it's remaining 1 times 1, 1/2. 2 times 3, 6. Is that clear? Good. B. P and Q, P only occur. P, probability that P only occur. Of course, if P only occur, that is P occur, Q did not occur, R did not occur. That's probability that P occur, Q did not occur, R did not occur. So that's probability that P occur is what? 1/2 times Q did not occur, which is 1/3, then R did not occur, 3/4. And that's 1 times 1, 1 times 3, 3 over, this is 2 times 3, 6, 6 times 4, that's 24. So 3 here 1, 3 here 8, 1/8. Then the C now, probability that none occur. That's probability that P did not occur, Q did not occur, then R did not occur. Probability that none occur, that is P did not occur, Q did not occur, R did not occur. And that will be what? P did not occur. P did not occur, that's 1/2 times Q did not occur, that's 1/3. Then R did not occur, that's 3/4. So we will cancel 3, then you have 1. 1 times 1, 1/2 times 4, 8. So that's it. That's probability that none of them occur. Then D says one of them occur. Probability that one of them occur. So probability that one of them occur with probability that P occur, Q did not occur, R did not occur, or probability that Q occur, P did not occur, R did not occur, or probability that R occur, P did not occur, then Q did not occur. That's the probability. So this will be what P occur now. P occur is 1/2. Q did not occur. You need to remember P occur 1/2. Q did not occur 1/3. R did not occur 3/4. Or means plus. Q occur 2/3. P did not occur 1/2. R did not occur 3/4. Or you say or means plus. R occur, that's 1/4. P did not occur 1/2. Q did not occur 3/4. So we said it's going to be one, just one. So if P occur, Q will not occur, R will not occur. Or Q occur, P did not occur, R did not occur. Or R occur, P did not occur, Q did not occur. So P occur is 1/2. Q did not occur is 1/3. Then R did not occur is 3/4. The second one, Q occur 2/3. P did not occur is 1/2. Then R did not occur is 3/4. Then the last one, R occur is 1/4. Then P did not occur is 1/2. Then Q did not occur 1/3. Q did not occur is 1/3, sorry. R occur, Q did not occur. So this is 1/3, sorry. this 1/3. So you now have it to be 3 will cancel 3, 3 will cancel 3, 2 here 1, 2 here, 2 here. This 4. Then you have 24 divided by 8, that's 3. 3 times 1, that's 3, plus 24 divided by 4, that's 6. So far so good. We have come to the end of probability. As I said earlier in the beginning of this video, we have gotten 3 videos on this particular topic. I want to believe that if you can lay your hand on these 3 videos, you would have become a guru as far as secondary school probability is concerned. Peradventure you have any problem with any of the videos, you can reach us through the comment section. We will provide answers to every solution, to every problem. So we will provide answer to every problem. Please do not hesitate to reach us using the comment section. Thank you very much. Before we go, I would like to charge us and to admonish us not to stop learning, because your growth is anchored on the number or on the volume of what you know. A man who refuses to grow will live a limited life. So don't stop learning and don't stop growing. God bless you all. See you in the next video. Thank you.